Hi everyone, my name is B. Mokshnath Reddy, Department of CSC from Karunya Institute of Technology and Sciences. Now I am explaining lab experiment 4 array implementation of circular queue. What is circular queue? A circular queue is a linear data structure in which the operations are performed based on FIFO, that is first in first out principle, and the last position is connected back to the first position to make a circle. It is also called ring buffer. See, this is the circle for circular queue, and this is the pseudocode for the circular queue, and the implementation we'll see in the later in the VS Code. In in this program, we'll, we will implement a circular queue in Python using a class unlike a linear queue. A circular queue connects the end of the list back to the beginning, which helps us to reuse empty spaces and avoid wastage after deletion. We perform the usual operations like insert, delete, and display by using modular arithmetic. Here we create a class called circular queue. Size size and we have to define in it in like size and self. Size stores the maximum number of elements allowed. Queue is a list of fixed sides initially filled with none. Front and rear are both -1 initially, meaning the queue is empty. For example, if size is equal to 5, we start with array none 5 times. Now we have to define insert self comma value. This function inserts an element into the queue. The first if checks for overflow when the queue is full. If the queue is empty, front is equal to -1, front and rear becomes 0. Otherwise, we move rear one step ahead. Circular begin. Finally, we place the new element at that position. For example, if we insert 10, 20, 30, 40, 50 in a size given 5 queue, then the queue becomes full. Now we have to define delete function. It will remove an element from the front of the queue. If front is equal to -1, the queue is empty, that that shows an underflow. If there is only one element left, we reset both front and rear to -1. Otherwise, we move front one step forward circularly using front plus 1 modulus size. The deleted element is displayed. For example, if the queue is 10, 20, 30, 40, 50 and we delete one element, if we remove 10 and front moves to next position. Now we have to define display function. It prints all the current elements in the circular queue. If the queue is empty, it prints a simple message. If rear is ahead of front, we print elements normally. If rear has wrapped around, we print from front to end and then from 0 to rear. This ensures all elements are displayed correctly even after wrapping. For example, if Q is equal to 40, 50, 10, 10, 20, 30, display will still print then the in order. Now we'll come into the main program. This part provides a menu based interface to interact with user. That means user should choose the options, that is 1 insert, 2 delete, 3 display, 4 exit. This part provides a menu based interface to interact with the user with the options 1, 2, 3, 4 given in the code. The loop continues until the user selects exist, not exist, exit. This makes the queue operations user friendly. So the conclusion. So this program demonstrates how a circular queue efficiently uses spaces by wrapping around the list and managing overflow and underflow conditions properly. Now we will run the code and we'll see the output. Now we will run this code and we'll see the output. See, it is asking enter the size of circular queue. Let me give 5. See, it is asking circular queue menu 1, 2, 3, 4 options. We have to choose from 1 to 4. Now I'll insert the number 44. Now again I'll insert one more number. Okay. Now I delete the number by choosing the 2. See, it is showing deleted 4. Now I will display the number. See, the queue elements are 55. Only 55 is because 44 is deleted. Now I'll exit from the queue. Thank you. That's it in this video, and thank you.